This is Cycle 1, Week 17 Science, and we're going to start with the scientific method. Scientific method, question, research, hypothesis, experiment, analysis, conclusion. So we're going to talk through the scientific method today as we explore rock bridges. These are the natural bridges that are formed in the earth, and we're going to kind of compare and contrast that to bridges that are man-made. And so we're going to show the class pictures of man-made bridges, and we're going to just talk through them. They may remember these from another cycle. We'll have to forgive my printer, it died, but these will be printed out nicely for you, and you'll have labeled pictures of different kinds of bridges, and we'll talk through what makes them similar, what makes them different, and we'll talk about how they're held up, what holds up these bridges. And then we're going to show them some pictures of some natural bridges, and we're going to compare and contrast those, and we're going to kind of talk through that, and we'll go through that today during the lesson. But our purpose today is that we are going to have the kids come up with questions about why natural bridges are strong and how they're made, and we're going to talk about how God made these so perfectly. And how they have lasted. Some of these bridges have been around for so long, naturally, and how man-made bridges wear out and decay and have problems and stuff. And not that that doesn't happen with natural bridges, but we're just going to kind of compare and contrast them and talk about why they work and why they don't. So we're going to ask a lot of questions in here. We will not have time to answer all the questions, but I think it's okay, and I know the Foundations Guide said we're getting children thinking and asking questions about science. And so it's okay to say, we don't have time to explore these questions today, but I want you to go home and investigate and come back and tell me, or write it down in your science journals or those kinds of things. So if they brainstorm 15 questions and you only have time to talk about 2, that's totally fine. So I wrote out a bunch of questions that are in here. You may or may not have time to go through all of them, but ask the questions anyway to get them thinking and wondering and questioning. So what have we already learned? We're going to talk about the forces that we talked about in week 17 that form rocks. We're going to come back to that this week, so hopefully that's fresh in their minds, and maybe they had a minute to sketch a picture in their science journals. We can flip back and look at that. We're going to talk about compression, and the definitions are in here. So what are compression forces, shear forces, force tension, compression, all these kinds, and we're going to talk about bridges and how when engineers make bridges, they are looking at all these different types of forces, and they're working against those forces, and that's all in here. And then we're going to talk about natural bridges and how they're formed and how erosion takes place and forms all these natural bridges, and all this is in here. So we're going to ask the kids, as our hypothesis section, we're not going to use nails, glue, or any other material to hold our bridges together using only books and chairs. Do you think that you can make a bridge? And so we're going to have a hypothesis there, and we're going to talk through that. We do a little demo at the beginning, and you're going to have 2 books, and you'll bring these from home, and you're just going to show them 2 pieces of paper and say, who thinks I can make a bridge out of these 2 flimsy pieces of paper that I can drive a car across? And some might say, no, you can't do that. Let them make their guesses and stuff. But we can talk about how when we have a force on the edges, and you have to put 2 heavy things on the other side to hold our papers flat. And so, yeah, we're just compromising working here. So have that right, 2 things that are here, and even though we're apart, we should be able to drive our car across our bridge. Let's see if I can get it to go across. It should hold it up. And so you can have the kids practice that or just show it. Even though paper, because forces are acting upon the outside of it, it's holding our bridge up. And so you can kind of talk through that. And that the script of what to say is in here. And so our experiment that we're going to do, that's kind of the demo. The experiment we're going to do is we're going to have 2 chairs that are of equal height and a stack of 12 books. So tutors, I will remind you the week before, we're going to need to bring in some books. It would just be way too many books for me to drag in for all the classes. So we'll just need 3 sets of 12 books that we bring. So maybe each tutor can bring in 6 books. And we want these to be larger, wider books, because we're going to have the kids stack the books up like this to make a bridge. And we're not going to tell them to do that way. Some of them will fail, and we'll learn from the failure attempts as well. So we're going to take 2 chairs and have them about 12 inches apart. And we're gonna have them try to first make a beam bridge, and they'll kind of work through that with the books, and we'll put them in groups and let them try it. So if we have a couple chairs in the room, we may have to bring in some chairs because the little chairs are curved edges. I think we may have to try to find some flatter adult-sized chairs to bring in. Or maybe 2 tables, because it wouldn't really matter what it is as long as they're 12 inches apart. Yeah. So we're going to have them continue stacking the books, and so they're overlapping, and they should be able to form a bridge that will hold weight on top. And so on the analysis section, no part of the bottom books overlap the edge of the chair. Each book above the bottom book extends over the edge of the chair until the top book is completely past the edges of the chair. So the one that's in the middle shouldn't be anywhere near the chair. So they should see a book sitting on top of air, so to speak. And so we'll talk through the different kinds of bridges and how this is like or similar to other man-made bridges. And in the conclusion, we're going to talk about not only are arch bridges some of the most beautiful rock formations, but they're also some of the most copied shapes in engineering. So way back, the Romans were making bridges like this because they looked at nature and copied it. I think this will go pretty fast. There is a really, really good video of a lady who explains all the different types of man-made bridges, and I think it's super helpful, partly because I'm not a civil engineer. I don't understand it all. She goes through all the technical science, so especially for the older classes, might be a really good video to watch. It's on YouTube. It's called What Makes Bridges So Strong. So if you have time for the olders, you may just want to show that. Otherwise, it might be something fun to send home for parents to watch with kids, so that would be great. What I thought for the littles who may or may not be able to get their hands on the books and make that work, some of them may not be able to figure that out, I thought it would be fun, so I'm going to bring in marshmallows and toothpicks, and we're going to ask them not to eat the marshmallows while we're making it, and then at the end we can give them a couple if that's okay with parents, but tell them this is a science experiment. We don't eat science unless it's been told that we can, but we're going to have them go at it and try to make some bridges. So give them 5 minutes and let them try to make a bridge out of toothpicks and marshmallows, and I'll have plenty that they can really go to town and make something. And then we can talk about how sometimes our man-made efforts aren't quite up to the effort, what God made just in nature, naturally occurring nature. We can talk about how that might not be as strong, and you can use your car and see, do you think it would go over? And I'm guessing we'll have some pretty wonky bridges to look at, but just to get their hands moving and have something to do if time allows. I think it'd be fun if they could just touch it and bring it in. If there's extra Ziploc bags, they could bring those home, and then if it's okay with parents, they can eat a couple, but I just brought that along as kind of an extension. So all objects behave as if their weight is located in one spot, the center of gravity. The book bridge is supported because the center of gravity is of each side of the bridge is over a chair. In nature, rock bridges are formed by weathering and erosion. These bridges balance because the particles making up the bridge overlap in such a way that they place the center of gravity in the structure over the supporting sides. So that's kind of the take home of it, very sciencey, but we want them to just see that where the big thing I think is the center of gravity and how erosion creates that bridge. So between the demo and the video and the marshmallows, I think we should be able to fill up our time. Just one more note for an extension activity with the marshmallows and the toothpicks, if you're working with that, have the kids looking at the pictures of the bridge and have them try to model it after one of those styles. So if they're trying to do an arch bridge or a truss, whatever. So just have them look at those bridges and try to model after that. So they're kind of remembering the different styles of bridges to link that to learning. Another fun extension is you give the kids, and I'll bring in some coins so that you can at least do a demo of this and send it home for them to try. Just give them a plain piece of paper and say, can you hold up pennies on just a piece of paper? And they will probably say no because it's flimsy. So you put it like this and show them like it's just gonna fall. But then if you either do it in an accordion or just fold up the sides like this will hold quite a few coins just by adding that extra support. The YouTube video I showed had a huge stack of coins on top. So you can have them, you can show them this and do one of the styles and then say, go home and see how many coins you can stack on just a piece of paper, or maybe shock your dad or whatever with what you can do. So just a fun extension activity to add to that.